welcome back. So this is going to be activity 3, system design. And the first part of this, I'm going to focus on the parts list, the justifications or input output devices. And I'm also going to do a quick, simple block diagram at the end of this. So let's get started. So here I have parts list. So these are all the parts I thought of that I could use for this system. Now, this is not an exhaustive list. This is just a few things I could think of quickly so I could give you guys an example of how this needs to be done. So I just created a blank table here just so this is what I'm going to use moving forward. You can use whatever method you prefer. Some people could do something like this. So let's say you have, you go to insert in Word, you go to table, and I highlighted something, insert table, and maybe do 3 things. So here we could have component. Here we could have a type of component, so input, output, processing, and here we could have the justification. All right, if this is how you prefer to do it, that's perfectly fine. And this way you could have every single component in one massive table. I don't like that option, so I didn't do that option. All right, but if that's what you prefer, again, that's perfectly fine. What I've done, I've gone ahead and created something like this, and I've simply highlighted all the parts that I want to use. So again, let me just quickly go through. I've got quantity on the left, and in the middle, I've got the actual component, and on the right where it says done, this is just whether or not I've gone through and done the justification table for that one. That's all it is, nothing special. So you don't even have to have this section over here. You could just use these two parts here. The components I'm going to be needing are the Raspberry Pi Pico with a micro USB cable. That's just the microcontroller itself. A Windows PC with Thunny IDE and MicroPython. Again, not necessarily a component of the system, but still something that I will need to use to create the system. I have a 16 by 2 LCD, so liquid crystal display. I think I'm supposed to have 2 of these actually, 2 LEDs, so 2 light emitting diodes. Let me zoom in. And I have 1 I2C adapter, 1 Hall sensor, 1 push to close button, and 1 buzzer. So those are all my components. So quickly think in your head, what are the things you need to create this device that you've been asked to create? Make your list. You can always add more onto the list later on, but this is just my initial quick out of my head thinking list, right? Oh, I forgot one thing actually. Well, 2 things. I need 2. So I've now added my 220 ohm resistors, and I'm going to say no here because I haven't done the table yet. So when I do the table, I'll come back and change it. So first and foremost, here we have the 16 by 2 LCD. So this is a component name, which we've done before as well. This is the component type. So input, output, processing, or other. I said this is an output device because again, it's an LCD. It's going to show information that the system wants it to show. The justification I've added here, a 16 by 2 LCD was chosen because it is simple to use. It adds a layer of user friendliness to the system, as there will be no ambiguity when it comes to how many items have been counted. So the good items, the bad items, the value can be displayed on the LCD. Very simple device, user friendly. It makes it clear as to what the system is actually doing. If me or myself as the engineer, I go in and I put prompts. So I say, print how many bad items, print how many good items, print how many batches of 10 there are, for example. My next component is called the I2C adapter. Only 1 is needed here. This is a processing stroke converter. I should really put stroke output as well because I'll be connecting this to the LCD itself. This was used to reduce the number of pins used on the microcontroller. The original was 16. This adapter makes it only 4. So it does some form of multiplexing on the inside of the chip. So it goes from it goes from 16 down to 4. Here we have LEDs. I only need 2 LEDs. I think I should probably put 1 green, 1 red. It doesn't matter. You guys can choose whatever colors you want. This is entirely up to you. If you have something like this, the choice is yours. That's an output device. A single, that's not TED, that's supposed to be red. A single red LED and a single green LED will be used as part of the notification system. They are simple to use while being small and incredibly effective. This will allow for people with hearing problems to quickly identify if there's an issue with the system. So as you guys saw at the top, I added a buzzer as well. So that's for people who can hear perfectly fine. And this LED is going to be for people who can see. So if you don't happen to hear the buzzer and you see a red flashing light or a red light that's constantly on the system, then there is an issue, right? Next, I've got Hall sensor. So only 1 is needed, and this is an input device. This will be used to measure the magnetic field. It is small, cheap, and allows for accurate enough detection for this application. So Again, we need to detect whether the mount body has a magnet, I think, something like that. So I'm going to use a Hall sensor for this. You can use other sensors, but this is the one I'm going to use. It's cheap, it's small, it's relatively accurate. I don't need to worry too much about it. Next, I have a push to close button or a pressure pad. Only one is needed. And the reason I say pressure pad is a push to close button would not be ideal for an emergency stop for a system. An emergency stop needs to be something relatively large, something relatively rugged. So if in an emergency, people aren't going to slowly and calmly go and press a single button versus they see a big red stop sign, they're going to hit it as hard as they can, right? So that's why I said pressure pad as well, or push to close button. They more or less work in the same way. They have a threshold which they have to go past before you can activate it, right? So let's say you're pushing a button and you don't feel the click until you push slightly harder, slightly harder, slightly harder. Same thing. This is going to be an input device. This will be used as the emergency stop. This can mimic the action of a large pressure pad or an emergency stop button normally located on industrial machines. A push to close button is cheap and easy to incorporate or incorporate into the system. Very cheap device. You can get them for pennies on eBay. Next, we have the Raspberry Pi Pico, only one needed. This is the actual processing. So even though that they said we should only do input and output, I've gone again above and beyond and said, let me just tell them everything. Let me leave nothing to chance, because some of the examiners are saying, oh, well, you've given me all the input and output devices, but what are you going to connect this to, right? You're going to show me what is being connected to later on, but you haven't said what is going to be connected to here. So me, I'm going overboard. So the Raspberry Pi Pico itself or the Arduino, let me put Arduino over here. Arduino Uno or Arduino Mega, whichever one you prefer to use, is perfectly fine. I would most likely go with the Mega. It's only like a couple pounds more and you get a lot more inputs. You could also use, what did I say, the PIC microcontroller. There are so many devices that we could use, but I'm focusing on the Raspberry Pi Pico. So these are some alternatives there. Let me remove this. This is a processing device, very cheap, thumb-sized microcontroller with 40 GPIO pins. So GPIO means general purpose input output. So you can program some of them. Some of them are going to be the ground pin. Some of them will be the positive. I think this is a 3.3 volt device. So general purpose input output pins. So it can take inputs and it can also give outputs as well. Support all major communication types and can be programmed in both C and Python. Now, you can even justify why this is important if you really wanted to. You could say some of the others only use C. So I think the PIC microcontroller uses a visual programming interface, so like a flowchart type system, or it uses some version of C, whereas this uses C and Python. Python is a very popular language amongst young people, so you've seen it at some point, secondary school, primary school, here at sixth form, college, wherever, right? There are loads of tutorials online on it, so it was easier to learn Python versus C or easier to learn C versus something else. The documentation provided by the company is very good and it supports a multitude of other hardware components. It is super fast, uses a dual core processor and has plenty of RAM. The reason we mentioned super fast, you want something that can handle inputs as quickly as possible. So I mentioned before the Arduino uses, I believe it's a 16 megahertz processor. That's very, 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 very fast. 60 million times per second is very fast. However, this is even faster. And because it's cheaper, it's £5, £10, right? It's going to be a much easier device for most people to purchase. Next component I have is Windows PC with Thunny IDE and MicroPython, only one needed. Component type, programming support. Now, this is a bit of a fluffy one. Put whatever you want here. Justification, any operating system can be used. At my school, we have Linux and Windows. At my school, we have Linux, Windows, and macOS. I'm familiar with Windows. I am familiar with using the Thunny IDE with Python. Thunny also has built-in support for MicroPython and the Raspberry Pi Pico. So when I showed you guys in one of the previous videos in another playlist, you simply plug the Raspberry Pi Pico into your PC, go to Thunny, and you can change your settings on the fly and it just works straight away out of the box, right? I think I did this one twice. I2C adapter, that's fine. I'm going to skip that one. Buzzer, we only need one. It's an output device. The LCD and LEDs are visual aids, so for people that can see very well. There would ideally be a sound aid as well, or an audible aid, let's say, which allows for people with sight issues, so seeing issues, they have issues with their eyes, to be able to operate the system to some degree. So let's be extreme here. So let's say you're deaf or blind, right? If you're deaf, you're obviously not going to hear the buzzer. So the LEDs, if you can see that, is the LEDs are flashing and the LCD tells you what's happening, right? So you can operate the system to some degree. However, if you're blind, you can hear the buzzer is going to tell you what's happening. So the buzzer might have, if an item is good, it might go beep. If an item is bad, it might go beep, beep, beep. If an item is stuck in there and it's going to cause a fire or cause some issue, it might just go beep. So the person who can't see, let's say, they can hear that and they can take appropriate actions. If they know where the emergency stop is, they can do that. If they can call a manager, they can do that, whatever the case is. So this is how I would do my parts list and justification. Yours doesn't have to be like mine. Whatever you think is best for you is perfectly fine. Now, the next thing I want to do is to have a block diagram. Block diagram, very simple. I said I was going to use Microsoft Visio for this, but then I realized most schools or most students probably would never have used Visio before, and many schools just don't have it. So let me use PowerPoint instead. So I'm going to go to PowerPoint. I'm going to create a blank presentation, right? Let's just create a new thingy here. Let's get rid, well, we can get rid of that. We can also get rid of these because we don't need this on here. So you simply highlight it. So click on the line, delete it, click on that line as well and delete it. Or if you know the shortcuts very well, you can just press Control A for alpha, press delete, and everything is gone, right? Block diagram. I'm going to show the inputs on the left. In the middle, I'm going to show the Raspberry Pi Pico, which does the processing. And on the right, I'm going to show the output devices. Now, it doesn't matter what your output devices are or your input devices are, there's still going to be a block, hence the name block diagram. So if I go back to my Word document, the very first thing I have here is an LCD. So I say that's an output device. So let me go to Insert. Let me go to Shapes. I'm showing the entire process because I know many people wouldn't have used this before, so I might as well. In the middle here, I'm going to have my Raspberry Pi Pico, right? And on the right, let me just copy this because I'm lazy. On the right, what did I say? The first one was, that's an LCD. So I'm going to type LCD in here. Oh, LCD. Let me shrink this down a bit. After LCD, we have the I2C adapter. I'm going to ignore this for now because this links to the LCD. So I'm going to use LCD instead of I2C. And again, the whole point of this is so that we can use less pins. So we don't really care about it here. LED, yeah, that's one as well. So copy this again, put it here, and call this one LED. Next, we have Hall sensor. That's an input device. So paste that again, put it over here, and call this one Hall sensor. Next device we have is push to close button. That's an input device as well. So copy that, paste it again, put that there. I'm going to do push to close button. Let me extend this a bit just so we can see all the text. All right. After push to close button, we have the Raspberry Pi itself, which is in the middle. So let me just label that. RASP Raspberry Pi Pico. It could be Pico W. It could be Pico WH. Whatever thing you have. It could be Arduino Uno. It could be the PIC microcontroller, whichever you want, right? Actually, the H in the Raspberry Pi only means header, so you actually don't even need that, to be fair. After that, we have the Windows PC. I'm going to ignore that. Don't need to mention that now. The I2C adapter, I had that twice. I'm going to ignore that. The buzzer, let me copy this again. Buzzer, right? In my previous sections, I mentioned that I'm going to be having a text file, saving what's going on. So really and truly, you could put text file here as well because the system will output to a text file. However, for mine, I'm going to only stick with components. I'm going to leave it as it is and only use components. I believe that's all I need for this. I'm not going to mess with anything else. So that's your block diagram there. The only thing you need to do at this stage is to put arrows or lines leading into the microcontroller from the input. So maybe a good idea would actually be to, let's copy this one more time. Let's label this side input. Let's make that caps lock. Input. Let's call the middle one processing. And let's call the end one, obviously, output. So it's very clear what's going on. It doesn't have to look pretty. Once it gives the right information, you should be good to go. Maybe just color these something slightly different. But again, this is just me being picky. This is just me. Okay, so I've lined everything up now. I'm going to go to Insert. I'm going to go to Shape. And I'm going to go to the bendy arrow one. I think it's that one there. Yeah, the elbow arrow. And as you can see, when I do that, the dots come up around this one. So wherever you move your mouse, the dots are going to pop up. So this is why I think PowerPoint might be decent for this if you have the newer version to PowerPoint. I'm going to click on the very rightmost one. Click, hold your mouse down and drag it over to the processing thing, right? Let go there. And I'm going to go to shape outline. I'm going to go to weight and I'm going to make this about 3, 3, 4, whatever you think is a 4.5 looks decent for me. I'm going to do the same thing again. I'm going to go to insert. I'm going to go back to shape. I'm going to go back to elbow arrow and draw that same thing again. Now you could have copied and pasted the first one and that would have been perfectly fine. But just because I wanted to show it again, I'm going to go to weight, make it 4.5. There we go. Right? So this shows that these two are leading into this system over here. Now I need to show the Raspberry Pi leading out to individual components. So I'm going to copy and paste this one this time. So I click on it, do Control and C for copy, then Control and V for Victor for to paste that component. And after you've pasted it, there's this white circle. Just drag that white circle up and connect it to the Raspberry Pi in my case. Then I'm going to move this over, put it to LCD. I'm going to copy that again and show the process again. So again, when you copy, you can move it around first. The white circle on the left, you move it to the starting point. For me, is going to be the Raspberry Pi. The end point in this case for me is going to be the LED. Paste that one more time. Move it down so it's out of the way. Circle on the left, move it up to the Raspberry Pi or your microcontroller, then move it down to the buzzer. And that's it. It shows what's going into the system in the input part. It shows the processing is going to be done by the Raspberry Pi, in my case, the Arduino for you, or the the PIC microcontroller for some others. And it shows what's going to be used as output devices. So LCDs, LEDs, and buzzer in my case. So this is it. This is all you have to do for your block diagram. I recommend two things at this point. Save your block diagram as a PNG and also save it as a PDF and a PowerPoint. Reason being, you're going to put this as a PNG in your document, but you want to save it so that if the examiner can't see it properly because it's too small, they can always go and look in a different folder. So I'm going to just save this as it is now. So to save it, I'm going to go to File. I'm going to go to Save or Save As. I normally just go to Save. I'm going to browse. And I'm going to go to, I think mine is on my desktop somewhere. I'm going to go to Unit 6. I'm going to go down to Unit 6 exam folder. That's fine. I'm going to save it here as diagram, as block diagram. PowerPoint presentation, that's fine. That's now been saved. I'm also going to export this as a PNG, or you could just screenshot it. Whatever works for you is fine. To export as a PNG, you just go to File, you go to Export, I believe, you go down to Change File Type. Here we go, PNG, Portable Network Graphics. Click on that, then you go to Save As, and it's going to come up as a PNG. It's going to be saved in the same location, which is fine for me. I'm just going to click Save. So as you can see, it says block diagram, same name, and the format has now been changed to PNG. I'm going to save that. It's going to ask me if I want to use just one slide, all slides, or cancel. I'm just going to use one slide because I only have one slide in this specific one. So if you have more than one slide, you need to specify. And I can now close this. I can go back to my Unit 6 exam folder. And as you can see, I've got my block diagram PowerPoint there. So I'm going to open this again just so you guys can see it. That's perfectly fine. And I can always go back and edit this. That's the beauty of this, right? My PNG, which is here, right, opens file. I can zoom in, it still looks decent. Now what I'm going to do is insert that image into my Word document. I've shown you guys how to do screenshots before. This is just a different way to insert images. I think screenshot is probably the way you should use because it's way quicker, but just in case someone wants to do something else, that's fine. I'm going to go to insert. I'm going to go to picture. I'm going to go to this device. And now I need to browse to the location where it was saved. For me, it was desktop. Unit 6, Unit 6 exam folder, and it was block diagram. Boom. Insert. All you have to do at this stage is probably just crop away the empty white spaces because it wastes a lot of space. Right click on it, go to crop, get rid of all the white space you don't need, and that would be it. So the next section of this series, I'm going to probably show you guys how to do pseudocode and flowchart. I might stick to doing my flowchart in PowerPoint. Again, reason being, I have Visio at my school, but many students or many schools don't actually give students access to Visio because it's a program that not many people use. So it doesn't make sense for them to pay for it. So I'm going to show this process in PowerPoint instead, because every school should have access to PowerPoint, because every school has access to Microsoft Office 365, which gives you Word, Excel, PowerPoint, sometimes Microsoft Access, so on and so forth. Hopefully that was useful. If you guys have any questions again about this unit, drop them in the comment section below, and I'm going to try my best to answer them as quickly as I can. Thank you.